So last video, number 21. What are 3 ways an object can be charged? So the rest of the questions have to do with electrostatics and magnetism. And remember that gravity, electrostatic or electricity forces, and magnetism are all field forces. So it's like they're invisible force fields that are in space. You just can't see them. And so anyway, number 21. 3 ways that an object can be electrically charged. Conduction, when you by direct contact. Remember we had the Van de Graaff machine, and I brought the second metal sphere, and you touched it to the Van de Graaff machine, and then that separate metal sphere then shocked me because it was charging it through conduction. Induction is never charging by indirect contact. So this is direct contact, this is indirect, and the last one is by friction. So if you not only directly contact it, but rub the 2 objects together, you are literally rubbing electrons off. So rubbing objects together. Number 22, when you're combing your hair, you scuff electrons from your head. This is your hair. This is your comb. So you scuff electrons from your hair to the comb. So electrons are leaving your hair and going through the comb. So what charge does your hair become? So your hair was neutral. That's right. And now, so this is your head. All the electrons went away. Bye-bye, electrons. Maybe not all of them, but some of them did. And they went onto the comb. So now your hair, now it has less electrons than it did before, so your hair is positively charged. And the comb is negatively charged. And remember, opposites attract. The positive and the negative will attract each other. So sometimes, especially on a dry day, if your hair is dry, you can comb your hair, and sometimes your hair will stick to the comb. It definitely does it with the balloon, because the balloon acquires a negative charge, the hair has a positive charge, and they're attracted to each other. What is the difference between a conductor and an insulator? An electrical conductor and an electrical insulator. So an electrical conductor allows electricity to flow through. By electricity, I mean electrons, excuse me. So conductors, basically the electron configuration, the atomic structure of it, allows for electrons to flow through it very easily. Or they can move around, I guess you could say. Whereas insulators do not. Do not allow electrons to flow. So, when electricity moves, when you have the flow of electrons, that is called current, but that creates magnetism, right? Number 24 says what creates magnetism. So anytime that you have electricity that is moving, typically current through wires, we made our little electromagnets with the wire and a battery. The current was moving through the battery, or through the wire, excuse me, and so that created a magnet. So moving electrons create magnetism. And likewise, moving magnets. So if you have a magnet and you move it near a wire, that will create a current in the wire. And I think I brought that little generator to class that time where we cranked it and we lit the light bulb just by winding the crank. And all that thing was, or basically any motor, just has a magnet in it. And that magnet can move, like how wind turbines work. That magnet spins around, so the moving magnet generates, or pushes current through some wires. You can generate electricity. 25. Compasses point to Earth's north pole, and which is really the south magnetic pole. Just kind of rounding it. So remember, if we were to draw a huge magnet in the Earth, it's true that the geographic north, east, southwest kind of business, the geographic north is indeed still north. But if we were to draw a magnet inside of the Earth, that would actually be the magnet south pole. And the magnetic north pole would be down where the penguins live. So you can draw this. You've got South America down here, and you've got Florida over here. That's awesome. So one thing I forgot to mention on the thing that you may want to review, which is very, very similar to the gravity law, was how to find electric force. So remember, electric force was K, Coulomb's constant, times the charges divided by the distance between the charges squared. Charge is measured in coulombs. The charge of each electron is 1.6 times 10 to the negative 19th. That kind of thing. So I hope you found this video to be, or these videos to be useful, and I wish all of you the best of luck in taking your finals. See you later.